We'll come back to elimination versus substitution once we get our concepts clear on nucleophile and base. Now, one thing is very clear: base is going to react with hydrogen. Now, nucleophile is going to react with any species apart from hydrogen. Right. Another thing that we have discussed in the previous session, that if you have to abstract hydrogen, then hindrance is not a factor, because no matter how big the chain is, like whatever the branching is, if you have to abstract a hydrogen, you can come up from one side, get this tiny hydrogen away, and whole of this bulky chain will not matter. At least one side of hydrogen will always remain unhindered. So basicity is not much affected by hindrance. But in case of nucleophile have to get to the nub. It has to get very close to the antibonding and start pouring its electron into the antibonding. If you have a hindrance all around, this is the antibonding, it has to get very close to the antibonding. If you have hindrance, if you have bulky groups, then this nucleophile will never come close to the antibonding. So hindrance will have everything to do with nucleophilicity, not much to do with basicity. So this will be very much affected by hindrance. This much we understand, this much is easy. Now another point I'm going to mention, and this both the terms that we are going to use now, we will learn now, will be used many times ahead. There are two terminologies. One is thermodynamic control of the reaction, another is kinetic control of reaction. Now by now you must have studied thermodynamics in physical chemistry and kinetics in physical chemistry as well. Thermodynamics mostly deals with energy. You have thermodynamics first law, that's energy conservation law, thermodynamics second law, thermodynamics third law. Thermodynamics deals with energy conservation. Kinetics is the study of the time that the reaction takes to complete. You must have calculated T half, T1 by 4, those kind of things in chemical kinetics. So we don't have to use any theory of those chapters, but you must know kinetics is a study of rate of the reaction or the time required to go to completion, or time required for the 50% completion or 25% completion, whatever. It deals with the time of reaction, kinetics. And thermodynamics deals with the energy released in the reaction, how much energy is released in the reaction. Now there are two things we'll always be considering side by side in any given chemical reaction. Suppose we have a reagent and we have a substrate. The reactant which we call in inorganic chemistry, that is called as substrate here in organic chemistry, on which reaction occurs. So we have a substrate, we have a reagent. Now suppose this reagent is not hell lot of very highly unstable. It is quite stable, can be sustained in the reaction, can be there present for some time. So what will happen is, for the reaction what we have to consider, if these two are not very insanely unstable, then we will be considering the stability of the product. In organic, as we'll study a bit more, you will realize that there will be multiple products that will be possible in any given reaction. So we have to judge by reasoning which one will be the major product, depending upon the factors we have studied up till now. So what we will do in deciding the major product, we will see which product is most stable, depending upon which product is having chelation, which product is having hydrogen bonding, which product is having resonance, which product is having most hyperconjugation, which product is having least hindrance. Those kind of factors will come into, as we have already studied those kind of factors. Those kind of factors will decide which product is most stable. Alright, so that is one thing. Look to the stability of the product. Among all the multiple products which are possible, choose one which is most stable. So that is the thermodynamic aspect of the reaction. If you are looking at the most stable product will have least energy. And when you are reaching to the least energy level, most energy will be released during the reaction. So when you look at the energy or you look at the stability, both are directly related. You have lower the energy, more stable is the substrate or reagent, reactant, whatever. So when you look at the energy aspect, that means you are looking at the stability aspect. You choose the product as the major product, the one which is most stable. That is the thermodynamic aspect of the reaction. That is what we have been looking up till now in various junior classes. Another aspect to look is the kinetics of the reaction. Now suppose this reagent is insanely unstable. This reagent is not going to survive more than a picosecond. So this reagent have to react. The aim here would not be the most stable product. The aim here would be to get rid of this insanely unstable reagent. That would be our win. That will be our victory. The more fast we are able to get rid of this insanely unstable reagent, the more successful we are. So here the whole focus would be to get rid of this highly unstable reagent. Now suppose there are two sites in the substrate, right? One of the site is hindered. Let me term this as site 1. Another site is unhindered. Now suppose both these sites are capable enough to go for reaction. That means this R minus can come in and break its head over C2, or it can break its head over C1. Both C1 and C2 offers this R minus to go for reaction, and hence it can get rid of its negative charge which it is carrying, right? Now this C1 is surrounded by different groups all over. Now this R minus, it will be more difficult for this reagent to come close to C1 because of hindrance from all the side and get adjusted to a suitable position and and after that start transferring its electron. On the contrary, the C2 is stable, unhindered. The C2 is unhindered, then R minus can quickly come close to C2 and start pouring its electron into its orbital. That will be a fast process. And when it tries to come close to C1, sometime it gets hindered by this group, sometime it gets hindered by this group and goes away, then come back again get hindered, takes time to get settled to a particular position from where electronic transition is possible. Slow process. Here no hindrance, can come fast, start pouring its electron fast. Slow, fast. If you are dealing with kinetics, if you are dealing with time required to go for the reaction, this site offers the reaction to complete at a faster rate. This site offers the reaction to complete at a slower rate. When time is more important rather than energy, then this site will be more suitable site. Suppose the reagent is quite stable, it is not in a great hurry to go for the reaction, then it will choose that site which will provide most stable product. Then energy becomes important. Then suppose if C1 is such kind of site, and we will learn to see how to identify site which will give most stable product, but suppose C1 is such kind of site which is giving most stable product, then this reagent will come to C1, because if you are getting the most stable product, the energy will be least, and during the course of reaction most energy will be released. So when energy is important, reaction site would be C1. When time is important, reaction site would be C2. That means when thermodynamic aspect is been looked into, C1 will be the site for reaction. If kinetic aspect of the reaction is being looked at, C2 will be the site for reaction. Now, nucleophile and base. Which one will have a thermodynamic aspect? Which one will have the kinetic aspect? Base goes for reaction with hydrogen because abstracting hydrogen is easy. That means base wants the reaction to be completed at a faster rate. That means base would be more unstable reagent than a nucleophile. So if base is reacting with hydrogen, it has less time for survival in the system, so it wants to react fast. So the reaction of base would be kinetically controlled. That means we will not look at the stability of the product. The product which is most stable, that will not be the major product. The product which is fastest formed, that will be the major product, even though it may not be very most stable. Now we will discuss this once we solve problems. Things will become more clear, but for now, reaction of base will be kinetically controlled. For that matter, reaction of any unstable species will be kinetically controlled. They have to get rid of their charges, they have to become stable fastest. Alright, nucleophile are rather stable. That's why they choose to slowly pour its electron into antibonding, and gradually electron comes out of bonding and leaving group moves out. That's a slow process. Leaving group moving out is a slow process. Abstraction of hydrogen is a fast process. Now you must have a very good feel and sense of this. Now nucleophile is going for reaction slowly. That means nucleophile are relatively stable species. If nucleophile are stable, that means they will react selectively at that site, which will provide the most stable product. That means we are looking at the energy aspect. The most stable product means having least energy. That means during the course of reaction, most amount of energy would be released. That means nucleophile have a reaction which is thermodynamically controlled. Now we'll talk about this later, and when we solve some problems, things will eventually become more clearer. But for now, these are two important terms to get clinched with here itself. Reactions either would be thermodynamically controlled or kinetically controlled. Thermodynamically controlled means species involved in reactions are stable. They are not in great hurry. They can give some time to select the site that will give most stable product. Species here, kinetically controlled, are unstable. They don't have to worry for the stability of product. They are not concerned. The concern here is to get rid of those unstable species. So the site which offers least time of reaction, that would be giving the major product, even though that product may not be most stable possible product. Right? Thermodynamically controlled, kinetically controlled. So base, because they are reacting with hydrogen, they would they have less time for reaction. Kinetically controlled reactions. Nucleophile, slow reaction. Thermodynamically controlled reactions.